Hello, this video is going to be on Algebra 2 topic M.1, evaluate rational exponents. The shortcut is KJX. All right, so here we're going to be simplifying with rational exponents. Remember, rational means that it could be like a fraction. A ratio is something like 2 to 1, but it could also be something like 2 over 1 or 1 over 7. It doesn't have to have a 1 at all. We'll see that in a moment. All right, so these exponents, as you can see, are going to be rational. So what do we do when we have a fraction in the exponent? All right, so what I want you to be able to do is really change how a fractional exponent looks using what you know about radicals. So another way to write 1 to the power of 1/2 is the square root of 1, which, as you know, is just 1 because 1 times itself is 1. So if you want to think about it, the denominator of the fractional exponent goes on the outside in the index, and then think of the 1, the numerator, as the power. This is like to the first power, but that doesn't really change it, so you just kind of leave it. So when you have anything, x to the power of 1/2 is just the same thing as the square root of x. Okay? Similarly, if you had x to the power of 1/3, that would be the same thing as the cube root of x, and so on and so forth. If you had x to the 2/3 power, that would be the same as the cube root of x, but now you're taking this whole thing and you're going to be squaring it. So once you find this value, you would square your answer because of the 2 on the numerator. All right, so let's go ahead and do a couple of these. We said that this one is just equal to 1 because the square root of 1 is 1. All right, let's look at this one. Another way to write 64 to the 1/2 power is the square root of 64, which is just 8. Here, we're not having the square root because this is to the 4th power. This is asking us for the 4th root, right? So what number times itself 4 times makes 16? Well, 2 times 2 is 4. 2 times 4 is 8. 2 times 8 is 16. So since 4 times 4 is 16 and 2 times 2 is 4, let's try 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. Yep, it works. The 4th root of 16 is equal to 2. All right, now we have to the 3rd power. So let's see what this would be. 64 to the 3rd power, remember the denominator becomes our index, or what is the root that we're taking? We're taking the cubic roots. The cubed roots. All right, so the cube root of 64, what times itself 3 times makes 64? Well, let's see, 8 times 8 is 64, so it must be smaller than 8 because we have to multiply it 3 times. Let's try 4, because I know 4 can be made into 8. 4 times 4 would be 16, and 16 times 4 would be 64. There you go. So what number times itself 3 times makes 64? That number is 4. Right, here we have a similar problem. We already did a 4th root. Here's something a little bit different. All right, so let's go ahead and write this out as the 6th root of 64, right? But then whatever we get, we're going to put that to the 5th power, right? So whatever we get, when that comes out of here, we're going to put that to the 5th power, and then that'll be our answer. So let's first find the 6th root of 64. Well, remember, when we do exponents, it grows really fast. So it might be as small as 2. So I'm going to try that first. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2, 1, 2, 3, 4, 5, 6 is 64. Let me check that. 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. So what number times itself 6 times makes 64? That number is 2. So we're going to take our 2, and we're going to do 2 to the 5th power. Well, I'm basically just doing the same thing, but in the other direction, right? So I know what 2 to the 6th power was. What's 2 to the 5th power? Well, we said that right here. This was 2 squared, cubed, 4th to the 5th. That was equal to 32. So here, our answer is 32. All right, this is similar, but let's do one more of these. So here we have 25. And then the index is a 2, or just a regular square root. Sorry, that's a 2. It looks a little like a 3. Let me change that. That's a 2. And then whatever we get, we're going to put that to the power of 3. So the numerator, again, comes over here. That's going to be our exponent. The denominator is our index. So remember, we don't need a 2 here, but the square root of 25, that's just equal to 5. So then we take our 5 and we put it in here. And what's 5 to the 3rd power? 5 times 5 is 25. Times 5 again, 25 times 5, well, think of it like 5 quarters. If I have 5 quarters, I have $1.25. But here we're not using decimals, we're just using a normal 25. So we have 125. That's 25 to the power of 3 over 2, or 3 halves. All right, so now you know how to do them when there's not just a 1 in the denominator. When there's not just a 1 in the numerator. Let's keep going and see if we need any more skills in order to get past this topic. All right, similar problem. All right, here's a negative. Let's go over one of these. So what to do when the base is negative? Let's see. Notice how it's in parentheses. Let's just rewrite this as we know how. Remember, to the power of 1/3, the bottom is our index. So this is the same as writing it like this. What is the cube root of -1? So what this is asking us is, what times itself 3 times makes -1? Well, -1 times itself 3 times makes -1. Because a negative times a negative is a positive, and then you still have a negative left over. And 1 times 1 times 1 is 1. So this is -1. So the cube root of -1 is still -1. All right, let's try this one. What is the cube root, right, to the 1/3 power of -216? Well, a key hint in this question, well, what's the first thing that we know? First thing that we know is it's the cube root and it's a negative, so it's going to be a negative answer, because a negative times a negative times a negative is going to keep our answer negative. And then the other thing we know is it ends in a 6, so you would try numbers like 3 or 6 or 9, since to the cube root, it grows pretty fast when you put it to the 3rd exponent. Let's try 3. -3 times -3 times -3, that would be 9 times 3 is 27. Oh, that's not big enough. So let's try 6. -6 times -6 is -36. Times -6 would give us, yep, -216. So our answer must be -6. All right, this one's really similar, just to the 5th root. Here's a different type of problem. So here we have 81 to the -1/4 power. Now, when you have a negative power, what it's really telling you to do is to do the inverse of the base. So the inverse of the base really just means put 1 over it. So 1 divided by 81 is the inverse of 81. So we could rewrite this as 1 over 81 to the power of positive 1/4. And then we can rewrite that as the fourth root of 1 over 81. So let's think about this. What number times itself 4 times makes 1? Well, 1 times itself 4 times makes 1. And what number times itself 4 times makes 81? I think that would be 3, but let's check it. 1, 2, 3, 4. 3 times 3 is 9. And 9 times 9, yep, that's 81. So the fourth root of 81 is 9. So this answer is just 1/9. Here's our fraction, 1 in the numerator, 9 in the denominator. Whoops, and oh, look what happened, 1/3. Oh, I see what happened. You see what happened? Remember, we did 3 times 3 times 3 times 3, but I took this 9 here. The fourth root of 81 wasn't 9, it was 3. So I did the work right, I wrote the answer wrong. Sure, it's happened to you before too. Let's try one more. Here's a negative square root, excuse me, a negative exponent. All right, so let's try this one. Let's do this right. 27 to the negative 1/3 power. We could rewrite that as 1 over, remember, negative exponent means you write the inverse of the base, to the positive 1/3 power. And whenever we have a 1/3 power, we can write that as the cube root. So this is just the cube root of 1 over 27. Think of it as the cube root of 1 divided by the cube root of 27. So let's go ahead and think what that would be. Well, the cube root of 1 is just 1. And what's the cube root of 27? What times itself 3 times makes 27? Well, that's 3. 3 times 3 is 9, times 3 is 27. So this is 1/3. 1 in the numerator, 3 in the denominator. There we go. This time we got it. All right, hopefully this helps. And then once you get to 90, you should be good to go.